In this video, we are going to talk about concentration. Now, before we can start talking about concentration, we need to first look at the different types of solutions we have. So, a unsaturated solution, all that means is that you can put more solute into the solution. It has less than the maximum amount of solute in the solution. So we can add more solute and it will still dissolve. A saturated solution contains the maximum amount of solute. So you cannot add more solute and have it dissolve. So in this image right here, this is an unsaturated solution. And if we keep adding more solute, then we could have a supersaturated solution. This would also look like a supersaturated solution, or sorry, this would look like a saturated solution as well. Now let's say we add one more drop of solute. Then we get what is called a supersaturated solution. And a supersaturated solution is when you have more than the maximum amount of solute in that solution. So the solute actually precipitates out. And you can see it starts forming these crystals in the solution. So the solute precipitates out of solution. Supersaturated solutions are also very unstable, meaning that it's very hard for the water to completely surround the solute particles. And for that reason, the solute particles can come out of solution very, very easily. So a way that since we have so many different types of solutions, we need to have a way of talking about how much solute we have in the solution. And we do that using concentration. In chemistry, concentration is a way to compare the solute to the solution and the solvent in a mathematical way. Also in chemistry, the units we use for concentration most often are molarity. So the molarity of a solution is going to talk about the moles of solute in 1 liter of solution. So we have moles of solute in 1 liter of solution. Now, something you need to be very aware of is we don't really have a way of measuring moles in the lab. We have balances that measure grams. And so we have to remember how we convert between grams and moles. And that's because in lab, we measure substances in mass, and more specifically in grams. So we need a way to convert between those grams to get to moles in order to calculate our molarity. And we do that using molar mass. Let's get some practice with calculating molarity. In this problem, it asks us to calculate the molarity of a solution that is prepared by dissolving 73.5 grams of sodium cyanide to a final volume of 250 milliliters. So I know that molarity, which is given the symbol capital M, is equal to moles of the solute per liter of solution. So I need to figure out what are the moles of my solute and how many liters of solution do I have. So the first thing I'm going to do is figure out the moles of my solute. If I have 73.5 grams of sodium cyanide, well, like we just saw on the previous slide, we can use the molar mass of sodium cyanide in order to calculate the moles. So go ahead and calculate the molar mass of sodium cyanide. Pause the video as you do so, and then come back and we can go over this together. All right, so 1 mole of sodium cyanide is equal to 49.01 grams. Hopefully that is what you got as well. You might be asking, why did you write it in that way? Well, if you remember, our grams have to be on the top and the bottom. Whatever unit I have here, I have to have in the bottom of my conversion factor so they can cancel out. So my grams will cancel, and notice I'm left with moles, which is good because that's what I need in order to plug into my molarity equation. When we plug this into our calculator, 73.5 divided by 49.01, I get 1.50 moles of sodium cyanide. So I can plug that in up here. And then I'm going to divide that by the volume of my solution. Now, something you need to be very aware of is molarity has to be done in liters. So I need to change my units of volume to liters if I'm not given it in liters. So now I'm going to convert from 250 milliliters to liters. And we can do that using the metric system. So 1 liter is equal to 1,000 milliliters. And when we do that, we get 0.2500 liters. So I can take that number and plug that into my equation. And when I do this math, we get 6. My units are capital M, and we call that molar. So it's going to be a 6 molar sodium cyanide solution. Something you need to be aware of as well is that this can also be written as 6 moles per liter. They are kind of used interchangeably. Like we saw with the different types of solutions, you can have different amounts of solute. And if you change the amount of solute, then you're going to change the concentration. Dilution is the process of adding solvent to a solution. And when you do that, you make the solution less concentrated or a diluted solution. And that diluted solution is going to have a lower concentration. Mathematically, we can make this comparison using this equation here, this mathematical equation here. We have M1V1 equals M2V2, where M1 is the initial molarity, V1 is the initial volume, M2 is the final molarity, and V2 is the final volume. In lab, we use what is called a stock solution to prepare Solutions of lower concentrations. And these stock solutions are very accurately prepared, so you know exactly what the concentrations are, and they are used to prepare all of your diluted solution. This is usually a very highly concentrated solution. Is a highly concentrated solution. Man, I really ran out of room there. So let's look at an example of how we can use M1V1 equals M2V2. The presumptive test for LSD requires a 250 milliliter of 3.25 molar hydrochloric acid solution. Concentrated hydrochloric acid is 12.1 molar. So, how many milliliters of the concentrated acid should be diluted to prepare the solution? The first thing I like to do with this is identify all of my numbers and see how they fit together. So I have a volume and a molarity, and then finally I have a second molarity. Now, your concentrated solution is always going to be your M1. So that tells me that my M1 is equal to 12.1 molar. And if 12.1 molar is my M1, then my M2 has to be the other molarity, which is 3.25 molar. Notice that when you're diluting something, the concentration has to decrease. It just has to. That is the process of dilution. So it makes sense that the more concentrated molarity is going to be M1 and the less concentrated molarity is going to be M2. Now, for our volume, we need to solve for how many milliliters of the concentrated. So this volume is going to go with the concentrated molarity. So my V1 is what it is that we're trying to solve for, and my test requires 250 milliliters of the dilute HCl. So that is my V2. When I plug this into my equation, M1V1 equals M2V2, I want to solve for M1. So I'm going to divide both sides by M1 so I can solve for my V1. When I rearrange my equation, I'm going to get M2V2 over M1. Now it's just a plug and chug situation. I can plug my numbers into my mathematical equation, then chug them out on my calculator. So we'll get 3.25 molar times our V2, which is 250 milliliters, divided by our M1, which is 12.1. Notice I didn't change the units of volume to liters. I don't have to. And that is because my units of molarity are going to cancel out here. I'm left with units of volume, which is good because I need volume. And more specifically for this problem, I need molarity, or I need milliliters. So it wouldn't make sense to change my units into liters, just to have to go and change them back to milliliters. So when we plug this out on our calculator, we can take 3.25 times 250, see what that equals, and then divide by 12.1, and I get 67.1 milliliters. This answer should make sense. I should never have a V1 that is more than my V2. So V1 is always going to be less than, there we go, less than V2. And that's because we're taking a small amount of our stock solution to make a concentrated solution. And we're going to be adding water to our stock solution. M1 should always be greater than M2. This is a dilution problem, solution dilution. So whatever concentration I'm starting with, it should decrease.